You will have a lot of things at your lab table. You'll have 4 molar HCl, exactly 3 milliliters, measured out into this container. Some aluminum foil, those are your 2 reactants. You have a thermometer. You have a test tube to carry out your reaction in. You have a beaker, which you can fill with water, so that you will be putting your test tube into that when it's ready to react, to cool it down. You will have this tennis ball can, and you'll fill it about 3/4 of the way full with water. That's what you'll be submerging the syringe in to collect your gas. Notice that there are volume increments on this syringe so that you can measure the volume of the gas that's recorded. And you'll have this J tube, which will be able to fit into your test tube so that the gas can come out of your test tube, and it can be come out this end of the J tube, we call it, into your syringe, and you'll have a balance. On the wall in the room, there's also a barometer, which measures the pressure inside of the room, or atmospheric pressure. Record the mass of the aluminum. Take the aluminum foil, and you're going to just kind of wrap it in a loose coil. You will take your test tube, and you'll put the piece of aluminum foil in it. Make sure it's not too tight of a coil, because we want to make sure that the HCl that we add can reach all the surface area. Meanwhile, another person in your lab group can be preparing what you'll be collecting the gas in. Again, this is a tennis ball can filled up almost to the top with water, and we're going to be using this syringe to collect our gas. There's a top we're going to take off. We're going to take out the pump since we don't need it, and we're going to take this, and we want to get all the air out of it. So we're going to put it and submerge it all the way in the water. And then I'm going to recap it when it's completely submerged. So now there should be no air in there. There should be all water. I'm going to have a beaker of water nearby that I'm going to end up putting the test tube in. And I'm going to take my 4 molar HCl, and I'm going to pour it into the test tube that has my aluminum in it. Make sure you're wearing goggles and gloves. 3 milliliters of the HCl has already been measured out for you. This is 4 molar HCl. Okay. Notice that the aluminum's in there with the HCl, and it might take a moment for it to react. I'm going to take my J tube. So there is a stopper on top with a tube in there, which will allow any gas to come out. Okay, and I'm going to take the other side of it, and I am going to fit it under my syringe. And let me just move this out of the way so you can see a little better as I wait for the reaction to start. This is filled with water so that I can make sure that the temperature inside here is kind of the same as the temperature in here. It also cools down the reaction a bit. Since this is exothermic, it's going to generate a lot of heat, which will make the reaction go faster. Just to kind of slow it down and make sure I can catch all the air, all the gas that's being emitted into this syringe. Make sure that you're keeping track that the J tube is still inside of the syringe so that you don't lose any gas. So again, this now has no gases in it to start. As the reaction starts to happen, it's going to, the HCl and aluminum will react to produce the gas. It'll bubble through this syringe, and when the reaction's done, it should be able to measure the volume inside. Now just remember, anytime a gas is collected over water, once this syringe starts filling up with gas, not only will I have the gas, but I'm also going to have some water inside there, some water vapor. Since it's collected over water, once there's room for gases to be inside of that syringe, some of the water will evaporate and contribute to the pressure inside there. So I'm collecting not only the gas produced in this experiment, but water vapor. And you can see that there. It's being starts to pop up. Very cool. It's starting to slow down now. Once you feel as if the reaction is complete and you no longer see any more bubbling, you will see, if I raise this up, you can see that there is now gas inside of there, and I can use the volume measurements on here to figure out the volume of gas inside. Now just remember that we want to make sure the pressure inside is the same as the pressure outside, because we are going to be looking at the barometer on the wall. We are going to be measuring atmospheric pressure. We want to see that that's also the pressure inside. So to make sure that the pressure inside is the same as outside, we want to raise or lower the syringe without losing any of our gas, and then we can make a volume measurement once the levels inside and outside are the same. I can then take my thermometer and I can submerge it into the water, and I can assume that the temperature of the water is the same as the temperature of the gas inside. Make sure that you record your values to the correct significant figures based on the equipment. Remember what you are measuring from the scale plus one more significant figure. You can record the pressure that's in the room with this barometer. Notice there's 3 different units: millibar, centimeters of mercury, which are probably the most easiest to use, and inches of mercury. So if I want to do centimeters of mercury, okay, I can look at that middle scale, and that can tell me how many centimeters of mercury, and then I can change it into millimeters of mercury by just moving the decimal place over and looking at the black handle.